Principles of Bioproduct Separation, Module 5, Extraction, Segment 5, Fractional Extraction with the Stationary Phase. With me, Yusuf from Institut Teknologi Bandung. Previously, we have discussed about chemistry of extraction, batch extraction, stage extraction, and differential extraction. In this segment, we will discuss about fractional extraction with the stationary phase. Fractional extraction with the stationary phase is also called as Craig extraction after its inventors. It is an extraction technique where a light phase containing several solutes is contacted with a series of tubes containing initially pure heavy phases, which results to an isolation and potential purification of the solute of interest. This method is relatively small-scale and used almost exclusively for biological separations. It involves a series of tubes as shown in the figure. The tubes are like separatory funnels which can be gently shaken. When they are tipped, the light phase is decanted and the heavy phase remains behind. The system contains R+1 tubes, all but one of which are partially filled with solute-free heavy phase. The special zeroth tube contains initially solute dissolved in the light phase and pure heavy phase. The zeroth tube is gently shaken until the solute concentration reaches equilibrium. Then the light phase is transferred from the zeroth tube to the first, and the new light phase is added to the zeroth. Again, the concentrations are allowed to equilibrate. The light phase are moved to the next tube and fresh light solvent is added to the first tube. The sequence is repeated hundreds of times. The distribution of solute is illustrated in the right figure for the case of equal volumes and equal concentration at equilibrium. The fraction of the original solute that is in the tube R after n total transfers is given by equation 39. As the number of transfers n becomes large, equation 39 approaches a Gaussian curve as shown in equation 40. This profile has a maximum when r equals to np and a standard deviation equals to np times 1 minus p to the power of 0.5. For the next segment, we will discuss about fractional extraction with two moving phases. Until then, I am Yusuf from Institut Teknologi Bandung.